Okay, I'm just going to try and link a couple of concepts together here. So I've got a block, a 12 kilogram block on a plane at a 40-degree angle, and there's a frictional force of 3 newtons acting against that motion. Now, the first force is our gravity, okay? And this force here is made up of the mass times the acceleration. So it's mass times by g, which in this case we're using as 9.8. Now I can break this force up into two different forces. Okay, I can say if this is like my y-axis here, if I put one here, that's one of the forces acting, the opposite to the normal of the plane. And then I've got the other one acting this way, which is parallel to going down the plane. Okay, and there's my 90-degree angle. And because this is 40 degrees, this one here will be 40 degrees as well. Okay, so the force acting down the plane, okay, this one here, is going to be equal to mg sine of 40 degrees. Okay, because I've got opposite that angle and I've got hypotenuse here. Okay, then this one acting to the normal will be mg cos of 40 degrees in this situation. Okay, so when I'm looking at the resultant force, okay, there's an equal and opposite force acting back up, pushing up from the plane, which will equal this mg cos 40. Okay, and it's pushing down and it's pushing back up. I'm more interested in where it's sliding back and forth. Okay, so it's the other force which we're talking about here. It's pushing it down the plane is mg sine 40. Okay, and the other one, the frictional force, is pushing back up the plane, and that there is 3 newtons there. Okay, so we're only really interested in these two to work out the resultant force, basically. Okay, so when we're looking at this, let's get our mg sine 40, which is 12 sine 40. Okay, and I'm making this direction here, heading down the plane, the positive direction. So therefore, this here is 3 newtons going the other way. So take away 3. Okay, and when I work this out in my calculator, I get 72.59, approximately 72.59, as the newtons going down the plane. Okay. Now, next thing we're going to do is calculate the acceleration down the plane. What is it accelerating down the plane at? Now, we know from Newton's second law that force is equal to our mass times by our acceleration. Okay? Now, we know the force, we've got it here, acting down the plane. We know the mass, which is 12 kilograms, so we can work that all out. So we just go 72.59 is equal to the mass, which is 12 times by A. And then if I make A the subject, I end up with 72.59 divided by 12. Okay, so A is going to be equal to approximately 6.05. Okay, and that's meters per second squared, because it's acceleration. Okay, so that's our acceleration. This block will be accelerating down the plane at 6.05 meters per second squared. Okay, next one. We've got how far will it travel after 2 seconds? Okay, now we're really looking for the distance traveled. Okay, we've got acceleration, but we don't have the distance traveled. So we know that A is equal to dv dt, for starters. Okay? So what I could do is I could say that this dv to t is equal to this constant acceleration, so we're dealing with constant acceleration of 6.05. And if I want to work out the velocity, then all I do here is integrate both sides in relation to t, so I'll end up with 6.05 integrate in relation to t. So it's equal to 6.05, and I've got t here plus c. Now in this situation, plus c, we're looking at the situation where, well, let's say it was at rest, okay, at the, initially, at time 0. Then if it was at rest at time 0, then our initial velocity will be 0, and when I substitute in v is equal to 0 and t is equal to 0, my c value will equal 0 as well. So therefore, the relationship between velocity and time is just equal to 6.05 t. Okay, now I'm still not there. I need to find the distance travelled. Okay, so I know that velocity is equal to dx dt. Okay, where x is our distance travelled. Okay, and that's going to be equal to 6.05 t. Now, if I integrate both sides in relation to t again, I'll end up with x is equal to the integral of 6.05 t dt. Okay, and therefore x will equal 6.05 divided by 2 t squared plus some value c. Now again, to work out our c value, we need to look at, what's the displacement at time 0. So at time 0, let's make the position of this block here, okay, that where it is initially is 0. So at time 0, c is equal to, its displacement is equal to 0, so therefore c will equal 0. So therefore our displacement equation is going to be 6.05, okay, divided by 2 t squared. Now to work out the how far it's travelled in 2 seconds, all I have to do is substitute in 2 for t. Okay, so I'll end up with x is equal to 6.05 divided by 2 times by 2, because we're looking at time equal to 2 seconds, 2 squared, which when I solve for that, I end up with 12.01 meters. Okay, so that's how far it's travelled after 2 seconds down that plane, 12.01 meters. Okay, last one. What is the momentum of the object at exactly 2 seconds? Okay, now our momentum equation is momentum is equal to the mass times by the velocity. Okay, now we have an expression for velocity as well. We worked that out before. Okay, it's equal to 6.05 t. Okay, and if we're looking at exactly 2 seconds, then we know that the momentum is equal to 12 for the mass times by 6.05 times by my time, which is 2. Okay, so I'm just using this part, which was my equation for velocity, which is 6.05 times by t. Okay, and then we end up with our momentum being equal to 145.18, and that's kilograms meters per second. Okay, it's our momentum, and that's approximately equal to. Okay, thanks guys.